it is volume and surface area of a sphere. What's our objective, class? Get ready?
Volume and surface area of a sphere.
Very good. Today we're going to review a little bit about the volume of a cone, just to help you understand the volume and surface area of a sphere. So if you remember, if we took a cone and a cylinder that have the same height and the same diameter across, okay, that the cone takes up 1/3 of the volume of the cylinder. So we're going to now talk about how the sphere, right here, compares to a cone and a cylinder. And I think your eyes, once you behold the coolness of this, it'll stick with you and you'll understand the ratio of how the volume of the sphere compares, and then you'll remember the formula better. So I need a helper to come up with this. Got a steady hand that can hold. Lisa will come on up. You got to hold the funnel. We're going to fill up the sphere and find out how much water it can hold. Okay? So hold that in there tight, and we're going to pour. And I'm going to have you, do you mind, can you be in the camera? Do you mind being on YouTube? Sure. Okay. All right. So we're going to fill this up. Maybe I should have you scooch even closer this way, so just in case we drip, it'll drip into that. Oh, and we're full. Okay, so before we pour that into the cylinder, we're going to pour it into the cone because I want to see how it compares to the cone. To me, the cone looks bigger. That's what my eyes see it as. But we're going to have you, I'm going to hold that in there tight, and it'll kind of launch a little bit. There you go. And just in case it goes more. Now, did that surprise you? That half of a sphere with the same diameter and the same height is exactly the same volume as a cone. It surprised me. All right, so I'm going to have Liesel, let's, I don't spill this. We're going to now transfer it into the cylinder, start filling up the cylinder. So some of you might be thinking, wait a minute, I know how many cones fill in a cylinder already. So how many half spheres will fill in a cylinder? Monica? 2. 3. Okay, very good. So so we're going to hold this up. Okay, so here is one cone, or really half of a sphere. So we'll call it a hemisphere, right? Half. All right, let's do it again. So take your half sphere, take your funnel. When I was in college, I went to the U of U, and my favorite class of all classes was I got a minor in physics. I think Mrs. Belknap did too. My favorite professor was Williams because he did stuff like this every day. It was in that huge auditorium. And so his demonstrations were like 20 feet long. It was pretty fun. Okay, so let's transfer this over. Here's another half sphere. If you want to leave it down, you could. But do you see what I did? Look, if you cover there's a vent hole right here. If you cover it, it doesn't want to come out. And as soon as you let go, okay, so that now we have just put in two hemispheres worth, or a full sphere is filled into the cylinder. Hold that up high. What portion of our cylinder is full, Emma?
2/3.
It's 2/3 full, okay? So we could already just figure out, one sphere is 2/3 the volume of a cylinder. All right, let's finish it up. Let's fill out our last one. Fill this up all the way. A little bit more. This is where all the videos you watch on YouTube, this is the part where they speed it up in fast motion. Okay, we'll transfer this. I'll let you pour it if you want to. We'll just leave it down. So this is our third half sphere. So now we've got 3 cones worth, or 3 half spheres. I usually say 1.5. 1.5 spheres to fill that out. Thank you, Lisa. You did great. Okay, so let's look at the math. How I like to think of it, if this helps you remember, we just proved with water that a half of a sphere is the same volume as a cone. So that means this bottom is also the same volume as a cone, right? So we can say that the sphere takes up 2/3 of the volume of a cylinder. So with that in mind, if you were to compare the volume of a cylinder to the volume of a cone and a sphere, if this takes up 1/3 of a cylinder, and this one takes 2/3 of a cylinder, you see how it's balanced. These two added together adds up to one cylinder. Look at the math formula. If you took the volume of a cylinder, it's pi r squared, the area of the base times height, pi r squared h. Since a sphere is 2/3 the volume of a cylinder, okay, so a sphere is going to be 2/3 the volume of a cylinder. Let's see, 2/3 pi r squared times h. We're gonna replace this height. If my sphere fit inside here, from here to here is a radius, right? So if I went from here to here, I have 2 radiuses. So my height is the same as 2 radiuses. That replaces right there. If you simplify all that math, it cleans up to be this formula. Okay, volume of a sphere is 4/3 pi r cubed. What's the formula starting with volume equals? Get ready?
Volume equals 4/3 pi r cubed.
We're going to practice that a few more times. I'm going to keep asking you, so let's be ready. I'm going to let you write it down. As soon as you're done writing it down, look at me. Spencer wrote it already. Nice job. Jasmine's ready. Okay, Lexi?
Isn't the volume of a cone pi r squared times height?
1/3 pi r squared.
Oh.
Times, okay. Okay, Samantha's ready, Layla's ready, Rachel's ready. Jasmine?
You keep on saying pi r squared. Now you're saying pi
Pi r cubed. Pi r, we'll have to have a new joke for that one. Okay, so volume equals 4/3 pi r cubed. It helps you remember, volume is 3-dimensional, length, width, height. There's 3 dimensions. So you've got a 3 and a 3. So remember those for volume of a sphere, you've got a 3 and a 3. So let's try a practice problem. A ball with a diameter of 20 centimeters has a volume of how many cubic centimeters? Or sorry, has a diameter. Round the answer to the nearest 100 cubic centimeters. So we're going to first write the formula. Volume equals 4/3 pi r cubed. What's the formula starting with volume equals? Get ready?
Volume equals 4/3 pi r cubed.
Very good. 4/3 pi r cubed. So we're going to go 4/3 times pi times radius. Oh, wait a minute. What is my radius? Hold on. 10 centimeters. Very good. 10 cubed. 4/3 times pi times 1,000, which is, we're going to need calculators. So roll leaders, grab your calculators real quick. We're going to go 4 times 1,000, divide it by 3, then we're going to times it by 3.14. I always save my pi calculation for the very last step. Depending on if they want us to round, we're going to use 3.14 for pi. All right, who's got that? Annika?
I actually have a question.
Okay.
So when we got the formula, I got confused because first we were talking about the 2/3 pi r squared times height.
Oh, so in your mind you're thinking the 2/3, right?
Yeah.
That's the ratio of volume in a cylinder, but not for just volume of just a sphere. That little, this right here starts with 2/3 and you times by 2r and it changes it into 4/3.
And why though?
That's a great question. So why is it 4/3 pi r cubed? Okay, so if you take, all right, it starts with this, that we know the volume of a cylinder, okay? So I would like to look at it like this, okay? A volume of a sphere is 2/3 of this. Do you agree? So the volume of the sphere is 2/3 of this, and that's all they did there. Okay, so we're good on that. So then they took this pi r squared times h and they replaced the h with 2 radiuses, because that's how tall it is. Are you okay on that part? took your cylinder and fit your thing in here, your radius is here. Well, there's one more radius. That's the same as your height. Radius and radius is 2 radiuses.
Okay.
Okay, good. Now we're okay. And now you times the 2 by the 2, there's your 4. And the r times the r squared, and there's your r cubed.
But,
I just went over it fast because most students don't care and they won't remember anyway.
okay, so
Okay.
that, would it be, like, would it still work if I use the 2/3 pi r squared times height? Like, if I use that as my
Yes.
thing?
Yes.
Okay.
Yes, that's a great question. Jasmine.
I got the answer to your question.
Okay.
earlier.
What do we got?
Like overall?
Yeah. Final answer.
Okay. Rounded 2, which is at 4,200.
4,200, and we'll throw units on
What
there.
was the units?
I can't remember. Centimeters, what?
Cubed.
Cubed. Very good. Raise your hand if you did not get 4,200 on your calculator. Okay, we're good. All right, got one other concept for you and one more example. If you cut a grapefruit, say I slice it right here. Actually, maybe I'll slice it right here so I can draw it on the side. I got a circle piece of grapefruit that's about this big. If I slice the grapefruit here, going through the center, my grapefruit slice is this big. So this is called the great circle. What is it called? Get ready?
The great circle.
The great circle. It's the biggest circle you cut from a sphere. All right, surface area. If you worked for a maybe a factory that cut out leather to make softballs, if you notice the stitching, it came from pieces of leather they stitched together. So if I took that piece of leather, it's actually kind of rounded. There's 2 pieces like this. And so this one is going to wrap around this one, and this one's going to wrap around. That's how they wrapped around the stitching connection all together. But it's flat. It's surface area. It's 2-dimensional. It's flat. So there's a formula for this. It's 4 pi r squared. What's the formula for surface area? Starting with surface area. Get ready?
Surface area equals 4 pi r squared.
Think it's 2-dimensional, so it's 2D. Okay, 2-dimensional. There's your square. That if you remember, and there's no cube, so don't think of the 3 anymore. All right, so it's flat. It's 2-dimensional. 4 pi r squared. What does it? Get ready?
4 pi r squared.
4 pi r squared. So let's find out the surface area of this softball. It's 10 centimeters in diameter. So surface area equals 4 pi r squared. 4 times pi times, what's my radius? Hannah. 5 centimeters. So we're going to take 5, we're going to square it. Notice how I wrote the formula first. That makes sure I don't forget any pieces. I can show all my steps. I work linear. And my last step, it says use 3.0. First do it in terms of pi. And then do it by calculating pi in. So we're going to take 3.14 times it by 100. Ding, ding. There's 2 spots. Ding, ding. We get 314 centimeters squared. All right. Any questions on surface area? Right. If you can think of a good way to memorize that, and you want to share it with the class as we're going on, just let me know and we can share that. Because no one has come up with a really good way to memorize that. Okay, we're on 734. Take a stand up break.